All right, then let's just do a very, very, very quick recap about where we left off last class. Because I think everybody was really comfortable with where we left off last class, so we won't spend a whole lot of time reviewing it. But basically what we're doing is we are trying to find the percentage of a distribution that's in between two cutoffs. So to jog our memory, let's just do T together. What we're doing with these problems now is there's a process that we're following, and like I said, if we follow this process, chances are we're going to get these problems right. And the process is always this. Our first step is always to verify that this right here is a z-value. And if this is right here a z-value, if we're dealing with z-values, then we know that we're going to be looking at our standard normal distribution, which is a bell-shaped and symmetric curve. Then the next thing that we did was we want to annotate these values right here on the distribution. Well, we know that a z-value that's negative is going to be below the mean, so I'm going to put the z-value of negative 1.08 over here. And a z-value that's positive, we're going to put that above the mean, so over here we're going to have a z-value of 1.12. After we annotate those two numbers on our graph, we want to find out which direction we're shading in. Well, we want to be greater than negative 1.08. So greater than is to the right of it. But we want to be to the left of 1.12 since we want to be less than 1.12. So we're going to be to the left of 1.12. So therefore, we're going to be shading in this area right here. Is everybody good with shading in that area? All right. Oh, thanks. 1 point. I was saying it right, but I wrote it wrong. All right, thank you. So to the right of negative 1.08, but to the left of positive 1.21. Right? Or was I saying it wrong? Maybe I was saying 1.1. I don't know. Anyways, now the picture is right. The next thing that we want to do is we want to look up these z-values in our table. So again, if we look up negative 1.08 in our table that we've been using, then what we're going to do is we're going to go down to the first decimal place, which is negative 1.0. And then our second decimal place is 0.08, so we're going to come over here to the 0.08 column. And where these two things meet up, we get 0.1401. Is everybody good with how to look up 0.1401? All right, then that means that from here on down, right, our table is always telling us what's shaded to the left. We have 0.1401. Then if we look up z-value of 1.21 in our table, we're going to do the same thing. Come over here to 1.2, and then come up here where we would have 0.01, right? Again, remember that these copied kind of weird, so they don't have those initial values, but this one right here would be 0.00, this one would be 0.01. So then for 1.21, we're going to come down here, and we're going to get 0.8869. Everybody go with 0.8869? Then that means that from here on down, we have 0.8869, or a little bit more than 88% of our distribution. And if we want to find out what's shaded in between, we're simply going to take the smaller one and subtract it from the larger one, or we're going to get 0.8869 minus 0.1401. And if I can do this arithmetic here correctly, then we're going to get 0.7468. Which means that then between a z-value of negative 1.08 and a z-value of 1.21, we have approximately 0.7486 of our distribution. And that's pretty much where we left off yesterday, y'all. How do you guys feel about this stuff? Jogging everybody's memory about where we left off? Any questions about any of this? I have a few extra copies of these tables. Does anybody need a copy of the table? Does anybody need a copy of the notes?
Can I get a copy?
And a copy of the notes. Z, yeah. So what we're gonna do is we just went over this to jog everybody's memory. Table, yeah, right here. There you go. What we're gonna do is we're gonna give you guys some time to work through one of these. Table. Here you go. And then we can get down to Z. But let's do like a softball one first, and then we'll get down to Z here. So why doesn't everybody take a minute and see if you can do U by yourself? Does anybody need a little extra time? All right, then let's do U together. So again, how about you guys walk me through the process on U? What's our first step? Look to make sure that we have a Z right here, and we do have a Z, so therefore we know that we're going to use our standard normal distribution. All right, what's our next step?
Make the curve. Oh.
You would want to look up whichever on the chart.
So we're not looking up on the chart yet. We're missing one thing. Yep, we're going to just put these values on our graph. So we have negative 1.34, which is going to be below the mean. And then we have 2.22, which is going to be above the mean. Awesome. Now what do? We shade, right? So we want to figure out the direction that we shade. We want to be greater than negative 1.43, but we want to be less than 2.22. Does it matter right here that we're greater than or equal to negative 1.43? No, nothing changes about that. So we're still just going to shade these two things right here, or that region right there. All right, is everybody good with this? Now what do? Now we go to the chart. Cool. So if we look up negative 1.34, what percentage do you guys get?
0.1611.
Everybody good with 0.1611? And if we look up 2.22, what do we get? Everybody good with 0.9868? Point zero, what?
So negative 1.34 was 0.09.
Let's see. Negative 1.34. Where these two things meet is
I was
point
looking
zero.
at the other side. I
Okay.
caught myself on the next problem, but
Alright.
I had already done the damage on that one.
Right, but everybody's good with 0.0901. Alright, cool. 0.0901. And everybody's good with 0.9868? Right. Then what do we have to do to find what's in between? Subtract them. So we have 0.9868 minus 0.0901. Oh, goodness. 0.8967. Awesome. So that is U. Took up a whole lot of space on U. But I think everybody's good with how to find these now, right? All right. Then we'll skip all these other ones except for Z. Xavier asked to do Z, so let's do Z. All right, so let's just do Z together because I think you guys are getting the gist of these, right? Our first step is to verify that there is a Z, which we have. And then our second step would be to draw our distribution. Our third step is to annotate these values, and we have two really big negative values. So we have negative 5.79, or I should say like really small negative values, but I think you guys get the gist. We have these two things over here. Now, right, everybody good with this setup? Our next step is then to figure out where we're shading. Well, we're shading greater than negative 5.79, so to the right of 5.79, but to the left of negative 4.19 since we want to be less than that. So we're finding this shading region right here. And that's our setup. Now, our next step always is to go to our table to find these values, but if you try to find negative 5.79, you go 0, right? Why is it 0? Because our table only goes to negative 3.99, right? The smallest value that we can get is negative 3.99, and there we're already at 0. So, therefore, if we want to go to a smaller value, say negative 5.79, well, now we're definitely going to be at 0.0000, right? And again, our accuracy only goes to 4 decimal places. So therefore, we know that for negative 5.79, from here down, we're going to have 0.000. But the same thing is true if we look up 4.19, negative 4.19. Again, it's not on our table. It's too small for our table. So then here we would also be at 0.000. Right? Is everybody good with this? Now, if we want to find what's shaded in between, what do we always do? Subtract the smaller from the larger, right? I'm doing this with quotation marks now because they're all 0.0000. So therefore here, regardless, even if we subtract these two things, we're going to get that this is approximately 0%. Good? Everybody good with this as well? Any other questions? You guys good with these types of problems? All right. Then let's move on to something slightly different. So we're always coming back to similar topics, right? And with that I mean this, right? We started off the discussion with the fact that we're dealing with continuous random variables. And we said, hey, we're dealing with continuous random variables, so we're dealing with some kind of smooth curve. And we can have all kinds of smooth curves. So what we're going to try to do is we're going to try to always bring it back to a normal distribution. Because if we can bring it back to a normal distribution, then we can use our table, right? That was our first step in the process. Then we said, okay, if we have some values, how can we bring it back to a normal distribution? And we said, well, if we have these x values, and if these x values are normally distributed, one of the things that we can do to bring it to our table is we can change these x values into z values, and then we can bring that back to our table. Right? Is everybody good with that? All right. So now what we're saying is that if we have things in z, then we can go to our table and we can do those things that we just did. And what we first started doing last class was we only looked at one cutoff, which I think everybody's going to agree now is like a really, really simple case of what we can do, right? And then we said, okay, let's make it a little bit more complicated and let's have two cutoffs in there, right? And now we're all really comfortable with how to calculate out two cutoffs. Now what we're going to do is we're going to add another little wrinkle in there. We're going to see how we can deal with that. Well, here's the thing, right? What all of these other problems did that we just got done doing, they all had these z values in there. So that's why I kept saying, hey, our first step is to verify that this is a z. But for all the problems that we've done so far, it's always been a z. One way that we could put this problem right here from math symbols into words, so if we want to like make a word problem, but we're going backwards, right? We're not starting off with a word problem and then going to a formula. We're starting off with a formula and we're going back to a word problem. We could say, hey, find the probability of, right? We know that that has to be in there. Why do we know that that has to be in our word problem? Because we have P in parentheses, right? And that is probability of. So find the probability of z being greater than 0.53 but less than or equal to 2.37, right? So if we did this problem right here, that would be S, right? We're finding the probability of z being greater than 0.53 but less than or equal to 2.37, right? Now, in the real world, this doesn't make a whole lot of sense. You would never see a problem like this. Why not? If I said, hey, if I come to you and I said, I want to know the probability of a student at UNC Charlotte being less than 6 feet, right? That's a reasonable question, and I want to find the probability of that. Or it's just a percentage of the entire population here at UNCC that's less than 6 feet. That's a reasonable question. I would never come to you, and I would never ask you the question, hey, I'm trying to find the probability of a student at UNCC being less than a z value of 1.7, right? If I ask you that, it'd just be like, dude, what, right? Like, nobody would come up to you and ask you that question. We're always trying to formulate these questions in terms of the units where it makes sense, right? If I'm asking about height, it might be feet. If I'm asking about weight, it might be pounds, or so on and so forth. So chances are, if we see a question that we're trying to figure out, right, like a percentage of the distribution, that question is going to be worded in some kind of other units, right? So if we now go to this next section, that's what this next section does. This next section right here is telling you to find the probability that some variable x is between two cutoffs. So another way of saying that is find the probability that the height of a student at UNC Charlotte is somewhere between 5 feet and 6 feet, right? That's if we wanted to put this math formula back into words just like we did on the previous page, right? So everybody seeing the difference between the stuff that we're working with now? All right, well here's the thing though, right? If I come to you and I said, hey, X is normally distributed, the heights of students at UNC Charlotte is normally distributed, so we know that we're working with a bell-shaped and symmetric curve. And if I say, hey, find the probability that students are somewhere between 5 feet and 6 feet, we can't take that information and go straight to our table, right? Because nowhere on our table are we going to find 5 feet and 6 feet, right? So we couldn't like find our cutoffs and subtract those percentages because we can't find 5 feet or 6 feet on our table. So then what would we have to do? Yeah, I should have covered this up, right? But like we want to convert this to a z value. Because if this were a z value, we would be really good with dealing with those z values now, right? Like we've done this a whole lot. But if this is an x value, we're just not very good with dealing with x's. Right? No pun intended, right? So if we could somehow convert this x into a z value, we can go back to our table and we would be good to go. Right? Is everybody good with that? All right. So now the question always becomes, and I asked you guys this question last time, I'm going to ask you the question again, even though it's kind of already up here. How do we convert an x to a z? Exactly. We're going to subtract the mean and divide by the standard deviation. And if we take that x value and we subtract the mean and divide by our standard deviation, lo and behold, our x changed into a z value. So that's exactly what we're doing here. Now, the important thing to remember is this, and this is a very, very, very basic math concept that all of you have mastered. If you have some equation, right? You have some equation, right? Let's say x plus 3 is equal to y, right? If I wanted to solve for x, what would I do? Subtract 3, right? But the important thing is that you're not just subtracting 3, you're subtracting 3 from both sides, right? So then here what we would get is that we would say, hey, I'm going to subtract 3 from this side, but then therefore I also need to subtract 3 from that side. So then I would get y minus 3 is equal to x, right? If we wanted to solve for x, we had to subtract 3 from both sides. The really fundamental math concept behind this is, whatever we do to one side of the equation, we have to do to the other side of the equation. Well, that's the same thing that's happening up here. Whatever we do to A, we also have to do that to X. And we also have to do that to B. We know that if we have an X, and we subtract the mean and divide by the standard deviation, now our X became a Z. But because we did that to the X, we subtracted the mean and divided by the standard deviation, to convert our x to a z, we also have to take A and subtract the mean and divide by the standard deviation. And we also have to take B and subtract the mean and divide by the standard deviation, right? So basically, we're just going to subtract the mean and divide by the standard deviation of all these things. Then what's going to happen is this, right? If we go back to that question I just asked you guys a second ago, and we said that A was 5 feet and B was 6 feet, right? I asked you what's the probability that the height of a student at UNC Charlotte is somewhere between 5 feet and 6 feet. Well, now what we're doing is if we're subtracting the mean and dividing by the standard deviation, this right here is just going to be some number, right? Because here if you take 5 minus what the average height is, I have no idea what the average height is, but we'll call it 5'5", right? Divided by the standard deviation, this is going to be some number. And then this over here is going to be some number. So all we're going to have is the probability of some number less than z's less than some number, and voila, we're right back to the types of problems that we just got done doing. Right, is everybody good with that? All right. So what we're essentially just doing here is, and I mentioned this on a previous graph, but here we're just saying it again in a slightly different terms, is that these x values that we have, these are all normal random variables. And we can have a whole bunch of different kinds of normal distributions, right? You guys remember that graph that I had up here yesterday that looked something like this, right? We can have a whole bunch of different normal distributions, but by subtracting the mean and dividing by the standard deviation, right, which is basically what it's doing down here, we're going from a normal distribution to a standard normal distribution. So we're going from x values to z values, right? So that's just, again, saying this stuff in pictures. But now we're here with this, right? Let me cover this up right here real quick. So try not to peek, because I'm going to ask you a question about that. Here, we're asked to find the probability that x is less than 14. If you wanted to do this calculation by converting this x to a z, what do you have to know? The mean and the standard deviation, right? So that's why I had this right here. I had it covered up because what these problems are going to start doing now is, instead of just asking us the types of problems that we saw earlier, where it's just straight up, like here's z in between two values, find it. Now what we're going to start to find is we're going to say, hey, here's an x value, here's a mean, and here's a standard deviation. Now find the probability of this thing, right? So the reason why I point that out is this. A common complaint that I get around this time in Chapter 5 is, hey, I went and I did the homework, and the homework is a bunch of word problems. And the stuff that we're doing now is just a bunch of like these simple little equations. That should not throw you for a loop, and here's why. You're going to go through these things, and it's going to say something like, there's a beautiful campus in Montgomery, Alabama that has a student population that has an average height of something and a standard deviation. Right? It's a bunch of these flowery words that contribute absolutely nothing to the mathematics. The only thing that we're trying to find is, what is our x value less than or greater than or in between? And what is the mean and what's the standard deviation? In that word problem, it's going to say something like average or mean. And in that word problem, it's going to say something about a standard deviation. That's the only parts that you need to pick out, right? You don't need to worry about all this other wording stuff as long as you can pick this stuff up. All right, is everybody good with that? Yeah.
Is that 14, is that a percent? Because those word problems keep asking about the
Percent.
right.
So
15% or something like that.
yeah, so those problems are types of problems that we haven't gotten to yet. We're going to get to those after this section. Because we really just have one kind of percentage here in these problems. The only percentage that we have is this thing right here, the probability of or the percentage of, right? So what we're going to start to see later on is, we can foreshadow that here real quick. What we're always doing, and we have always been doing so far, is that we're either given an x or a z, like we did in the previous problems, and we're given two cutoffs. And we've always found the percentages or the probabilities. But if you have an equation, right, and you're trying to figure something out, we've always tried to figure this thing out so far. But what happens if they tell you that, but leave away a, x, or b? You should still be able to solve it, right? Because now you're just missing one piece of information, but you're given the probability instead, or the percentage instead, so you can kind of do the arithmetic to work out the opposite way too. And those are the types of problems that we haven't gotten to yet. Yep, but we'll get there by the end of today. Great question. All right, so let's do this. We're trying to figure out the probability that x is less than 14. So we said that if we wanted to do this, we want to convert our x to a z value. The way that we convert our x to a z value is we subtract the mean and divide by the standard deviation. But whatever we do to one side of the equation, we also have to do to the other side of the equation. So therefore, we're also going to take the number 14 and we're going to subtract the mean and divide by the standard deviation. Right? All right. Well, now what we realize here is this. We've just converted this x to a z value. So I'm going to write this as the probability of z is less than, right? That was the whole objective for that left-hand side of the inner part of this equation, right? We've now converted this x to a z. And now what we want to have is, if over here were some number, we're just right back to the type of problems that we did last class, right, at the beginning of last class. So what we can have here then is 14 minus, we know that the mean is equal to 10, and we know that our standard deviation is 2.5, so we can plug those numbers in for mu and sigma. And then what this is going to come out to is the probability that z is less than, oh gosh, did I do this? Hey, I did this. Perfect. Is less than 1.6. Everybody good with 1.6? All right. Well, now we're just right back to the types of problems that we did at the beginning of last class. We could go through our whole process of, is this a z, right, blah, 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 blah. But I think you guys are comfortable with that now, right? So essentially what we're going to do is we're going to look up 1.6 in our table. If you look up 1.6 in our table, what do you get? 52. So 0.9452, is that our final answer, or do we want to subtract that from 1?
Subtract it.
No, because it's going on the side.
Still says less than.
Haha. All right. Cool. All right. So we all know, we're going to go through the process then, right? We all know that this is a z, so we can use our normal distribution. Next thing is we record this number of 1.6, which is positive, so it's above the mean. But we want this to be less than 1.6. So which way are we shading? To the left. Is that the same direction that we have in our table? So if we look up 0.9452, we look up 0.9452, do we subtract that from 1? Good. We do not subtract that from 1. 0.9452. Is everybody good with 0.9452? So, really, once we get to this point right here, it's just like the problems that we've been doing since yesterday, right? The only new thing is that very first question that I always included in that process was, is this right here a z? And now we're answering that question with no. This is not a z. So therefore, now we have to first convert this to a z. So once we get to this point then, right, we're doing this arithmetic, we end up with z is less than 1.6. Now we're just right back to what we've been doing all along. So the only new wrinkle that we're adding in is that this is an x and not a z. Everybody good with that? All right, then take a minute or so for yourself and see if you can do b by yourself.
Do you have a question?
Yes.
Rounding.
Yes.
So you end up finding your z value and adding 1.6 repeated.
Yeah.
Do you round at any decimal?
Good question, right? So I think what you're asking here is this, to make sure I'm understanding you right. Let's say that this number that we came up with was not 1.6, but it's 1.66666. That's what you're asking, right? Cool. Our z table is always to 2 decimal places, right? So therefore, you're always going to round this number to 2 decimal places, and you're going to round these numbers just like you would round any other number. If it's equal to or greater than 5, you round up, and if it's strictly less than 5, then you round down. So it's not the same thing as when we were doing percentiles that we always rounded up. It's just you round just like any other number. Great question. Does anybody need a little extra time? All right, now let's do this one together. Let's go through that process so we can identify what's different here. Our first step always in the process is to ask whether or not this right here is a z value. And it's not, right? So therefore, the first thing that we have to do is what? Make it into a z value. Cool. So if we wanted to make this x into a z value, what do? Awesome. And whatever we do to one side of the equation, we have to do to all parts of the equation. So then we're also going to have 9.5 minus mu over sigma. Everybody good with this? All right. Well, now we just converted this to a z. Now what do? Awesome. We can plug in the values that the problem gives us for mu and for sigma. And now what do? Do that arithmetic over there so we know what that's equal to, right? And like Joshua asked, here this comes out to negative 1.67, right? Because our z table is always to 2 decimal places. So therefore it's technically negative 1.66666, but if we want to look up that z value in the table, we have to have it to 2 decimal places, so we just round to negative 1.67, right? Is everybody good with this? Yep. Negative 1.6166. Did somebody else get that? Good? Alright, awesome. Those phones, they'll get us every once in a while, right? Alright, cool. Everybody good with this? Alright, and then after this, I think we're all good, right? Because now we're just right back to one of those problems that we started at the beginning of last class. If we look up this, we're going to get 0.0475 from our table. Is that our final answer? Yes, it is our final answer. Is everybody good with this being our final answer? How do you guys feel with these types of problems? Good, right? Just a tiny little wrinkle in there. All right. This next problem right here, what's different between this next problem between C and what we just got done doing? It's greater than. So what's going to change about this? We're going to subtract it from one at the very end, right? Everybody feel comfortable with that? Other than that, nothing changes. So we'll skip this one right here. Let's do D. Why don't you guys take a minute for yourself and see if you can do D. Does anybody need a little extra time? All right, let's do this one together. So again, let's go through the process, right? The process says to check to see if this right here is a z value. It's not. So therefore, our first step is going to be to convert that to a z. Now, one of the things that we're changing is that we have two cutoffs. So if we want to convert this thing to a z, we're going to subtract the mean, and we're going to divide by the standard deviation. But what I've always said is whatever we do to one side of the equation, we have to do to all sides of the equation. So therefore, we also have to subtract the mean and divide by the standard deviation over here, and also subtract the mean and divide by the standard deviation over here. In this problem, over here on the left-hand side, we have the number 5, and here we have the number 9.5. All right, is everybody good with this setup? All right, then we just converted that middle section to a z value. And here what we're going to have is 5 minus our mean, which is 7, divided by sigma, which is 1.5. And over here we're going to have 9.5 minus the mean, which again is equal to 7, divided by our standard deviation, which is 1.5. So we plug in those values, we get this. If we do this arithmetic, we're going to get, this is negative 1.33 is less than z, which is less than or equal to 1.67. Is everybody good with this so far? Any questions about this? And then we're right back to the types of problem that we ended last class with and we picked up with today, where we have a z value, but we have two cutoffs. Again, one of the things I don't think I've mentioned today, so let me ask this again. Does it matter whether this is less than or equal to or just strictly less than, right? Equalities just doesn't matter. So therefore, if we go and we look this stuff up in our table and we subtract the smaller one from the larger one, what do we end up with? 8607. Everybody else get 0.8607? Question?
Yeah, if the number is negative, it doesn't. The number is just because it's negative does not necessarily mean that this number on the chart will be smaller, right? You have to always go by the value that you find.
Right. So I think if I'm
number is negative, it's these four numbers on the chart could be bigger still.
So what just to make sure I'm understanding your question correctly, here if we're dealing with z values, we're always dealing with a normal distribution. And what we're always saying here is that here it's going to be centered on 0. So over here we're going to have positive values, and over here we're going to have negative values. The z values is always telling us where we're going to stop shading into. But our table always shades in from the left, right? So therefore, if we have a z value, let's just use negative 1.33, and we have a z value that's, negative 1.0, say? Well, negative 1.33 could be like right here, but negative 1.0 is going to be to the right of it. So therefore, as your number gets bigger, and technically speaking, negative 1.0 is bigger than negative 1.33. As your z value gets bigger, the percentage of the graph that you shaded in was also going to get bigger. Right? Always bigger, right? So therefore, over here, if we look at these two numbers, this one is smaller than this one. Negative 1.33 is less than 1.67. So if we look this one up in the table, we should get a smaller percentage than when we look this one. Okay. Does that make sense? Now, just to make sure, like I said, to understand your question correctly, if for some reason we don't end up with this, let's say for some reason we end up with this right here. Right? Where the only difference that I have with these two things is that I just changed the direction of these symbols. Right? This symbol right here and this symbol right here. Well, how is that going to change our calculation? Well, if we make this into a picture, right, Then here, are we dealing with a z-value? Yes, we are. We get to use our normal distribution. We're going to annotate these two values. Here we have a negative 1.33, and here we have a positive 1.67, right? Nothing's changed there so far. But now, if we decide where we're going to shade, here, if you just read this portion right here, which way are you shading? To the left, right? Because you want your z to be less than negative 1.33, right? So here now we're shading to the left of negative 1.33. And then that's good enough. And then here, if we just look at this portion, we want it to be greater than 1.67. Right? Is everybody good with this? So therefore here then we would say to be greater than 1.67. So just to make sure that I'm understanding your question correctly, if we look this thing up in the z table, it's always going to give us a smaller percentage like this. But that doesn't necessarily mean that we always subtract the smaller one from the larger one. Because here, if you want to find this out, you're not finding what's in between. And if we want to find what was in between, we subtracted the smaller from the larger. Right? You go with this? But now what are we going to do if we want to find this? We haven't done an example like this yet. So let's do it. If we look up the z value of negative 1.33, our table is going to give us what's from here down. Right? Does everybody go with that? If we look that up, what did we say we get? Negative 1.33, we get 0.0918. Right? Is everybody good with 0.0918? 0.0918. If we look up 1.67 in our table, again, and very, very importantly, that's why I always, whenever we look this up, I always drew it out like this. If we look up 1.67 in our table, 1.67 gives us 0.9525. So from here down, we get 0.9525, right? But now I think everybody will agree that I'm not trying to find what's in between. So I'm not going to take the larger one and subtract the smaller one from it. Otherwise, I'm figuring out what's in between. Right? Is everybody good with that? Now what I want to do is, I know from here down I have 0.0918. And I want to take that amount and I want to add it to this amount. Right? To give me the total shaded area. Well, how do I find out this amount? 1 minus this, right? So I'm going to take, in order to find this out, I'm going to take 1 minus, there, now you guys can see it, 0.9525, and that's going to give me 0.0475. Right, is everybody good with this? So I know now that over here I have 0.0575, and over here I have 0.0918. So now if I wanted to find the total shaded area, I'm just going to add those two things together. And let's see if I add, I'm just all over the place up here, right? Now I'm writing over here on the left. And this is going to be 0.1393. Right, is everybody good with that? So, let me just quickly recap that just to make sure that I'm answering your question because I wasn't 100% sure what you were asking. But, this right here is always going to give us a smaller percentage than this right here if we look it up in our table. However, whenever we're trying to find the shaded region for what we're looking for, that doesn't necessarily always mean that we're going to take the value from this one and subtract the value from this one. We're not always just going to take a smaller one and subtract it. Because here we're getting a smaller percentage, 0.0918, than we would from over here. But here we're just going to add this percentage to this percentage over here, so we have to do it a little bit different arithmetic, right? Now, technically speaking, writing the problem like this right here, like I wrote it, that's kind of like saying ain't in mathematics, right? Like, it's technically not correct, but if you try to do that in your English class, you're going to get points taken off for that in your English class, right? technically speaking, what we always want to do is that we want to write this, we want to write it from left to right, smallest to largest, right? So here what we're doing is we're going from largest is less than z, which is less than negative 1.33. If you just take out this portion right here, you're kind of reading it as negative 1.33 is greater than 1.67, and that's technically not correct, right? So the way that this problem should be written, now I'm going to take another piece of paper because I've sufficiently scribbled all over this, is we would say, what's the probability that negative 1.33 is greater than z, or the probability that z is greater than 1.67. And now this is grammatically correct. Right, does that make sense? It's essentially kind of getting at the exact same thing. All right, any questions?
I think I need some more practice, but
Does that make sense though? Like the
Yeah.
kind of like the overarching
pretty much you
concept?
have to just follow the rules.
Yeah, and that's why, like what I said whenever we first started this chapter is, I like to show you guys a process. If you guys follow that process, we're starting to get this right. And then in that process, we always said, okay, which direction are we shading from here? Well, here we want to have it less than negative 1.33, but here we want to have it greater than that. So if you shade according to the process, should be getting them right. All right, you guys want to do E? All right, let's do E. Take a minute or so for yourself and see if you can do question E by yourself. Oh. Does anybody need a little extra time? All right, then let's do this. So, again, if we follow the process, the first question that we ask ourselves is this a z value? It's not a z value, so we're going to convert this to a z. The way that we convert an x to a z is by subtracting the mean and dividing by the standard deviation. But whatever we do to one side of this equation, we have to do to all sides of this equation. So therefore, we're also going to subtract here the mean and divide by the standard deviation, and also on the right-hand side. Well, then we have successfully converted this middle portion right here to a z. And what we can now do in these other two sections is substitute in the mean, which here in this problem is given to us as 24, and the standard deviation, which here is 3. And then the same thing over here for the right-hand side. If we do this arithmetic then, we're going to end up with negative 2.33 here. And on the right-hand side, we'll end up with negative 0.67. Everybody good with these numbers? If we see, so now we're just right back at where we had done the previous examples. Right, so from this point then, I think you guys are good. And what's the answer that you arrive at if you go through the rest of the process? 0.2415. Everybody go with 0.2415? All right, you guys feeling pretty comfortable with these? All right. Then what we're going to do is, luckily we're going to go on to the next, we'll go on to the next page. I'll just explain this on the next page. I don't want to use this page anymore. I'm starting to remind myself of a professor that I had in graduate school. This guy was the worst professor I've ever had, right? This guy was so terrible. There was another one that was probably equally as bad, but this one professor, this was the only class that I dropped in graduate school. This guy, he would talk to the board all class long, right? And then he's talking up there, and he had the most atrocious handwriting. So you couldn't even ask him a question because unless you said, hey, I have a question, he wouldn't notice that you're raising your hand. Which I do that too, so that's no big deal, right? But anytime you ask this guy a question, which is such a complete ass, right? That you just didn't want to ask this guy a question because he'd say stuff like, well, clearly, it's this, right? You're just like, oh, all right, last time I'm asking you a question, right? But then he would write, and then he would just keep writing, and then he would get to the end of the board, and he would run out of room. So then he would start writing like this, and I kid you not, this guy would be over here for 10 minutes, scribbling in a corner, and then we're just like, great, I paid for this, right? Anyways. So I don't want to be that guy, right? I'm starting to write all over the page and stuff. I was like, all right, let me try to get things a little bit more organized. All right. Anyways, that was a tangent. What we're going to do now is the same thing that we've been doing before. We've always just changed up the process a little bit, right? We went from having z values with one cutoff, then we went to z values with two cutoffs, then we went to x values and converting those to a z with just one cutoff. Then we went to x values with two cutoffs and converting that to a z. Now we're going to have a slightly different thing, and the different thing that we're going to have is this. Let's break it first down to a basic math concept. Let's say that you're trying to calculate out a z value. Well, if you have some x value, and you have some mean, and you have some standard deviation, you can calculate out your z value, right? For instance, let's say that you had an x value that was 10, you had a mean that was, 12, and you had a standard deviation that was, 4 or something like that, right? Regardless of what these numbers are, if I told you to calculate out the z value, you could do that, right? That would be just basic arithmetic. Let's just do it here real quick. If you take 10 minus 12, you're ending up with negative 2. Divided by 4, you're going to get negative 1/2, right? So if we do this, then we would get that this would come out to negative 0.5. Right, so everybody go with that? Well, suppose that we did this. Suppose I didn't tell you this x value. Suppose I didn't tell you this x value. But I told you that z was equal to negative 0.5. Right? Would you be able to find x? Absolutely, right? Because all we would do then is, let me rewrite this. We would say that negative 0.5 is equal to x minus our mean, which is 12, divided by our standard deviation is 4. everybody in this room most certainly feels very comfortable solving for x. Right? Is everybody good with that? All right. That's basically what we're doing in this section. We're just saying, hey, find x. Right? Now, this is the definition from your textbook in this box. What they do is they just say, hey, now that we're finding x, they call it like x star, right? They have like a star in the x1, they're calling it x star. Basically, it's just to say, hey, find like the x value. But basically, all that we're doing is that we're set up with something like this, and we're trying to solve for x. So what we're calling right here x, they're just calling it x star because we don't know, right? The only other tiny little wrinkle that we're going to add to this is, what happens if I didn't tell you that this was a z value of negative 0.5? And I didn't tell you what x was. Well, now you have one equation and two unknowns, so that's not possible, right? But what they can do is this. Let's look up a z value of negative 0.5 in our table. If we look up a z value of negative 0.5 in our table, we end up with 0.3085. Right, is everybody good with finding a z value of negative 0.5? We're going to end up with 0.3085. So now, if they don't tell us what z is, and they don't tell us what x is, we can't solve this. But if they tell us here that the probability of something is equal to 0.3085, they're giving you the percentage. Well, now what you can do is you can say, hey, I don't know what z is. I don't know what x is. I need to find x. But they're telling me that the percentage of something is equal to 0.3085. So what you can do now is you can go hunting for 0.3085 in your table. Find out what z value that is. Take that z value, plug it back in over here, and then solve for x. Right? You see, so there's just like that additional step of hunting for the percentage in your table. Right? Everybody good with that concept before I say something else? Right? Everybody's completely comfortable with what we're trying to do? Anybody want me to go over it one more time? All right. You guys still remember whenever we first went over this table, one of the things that I kept saying is that these things in here are percentages. Your z values are just this column and just this row, right? Whenever we looked up z values, we always just looked them up in that column and that row. I told you guys when we were first going over this table that a common mistake that always tends to bubble up is that people start thinking that these are z values. These are not z values, right? Everybody's good with that? These are not z values, these are just percentages. The confusion, I think, starts to come in now in this section because what we're doing is that we're given a percentage. This is a percentage. This is not the z value. We look up the percentage now in our table to find the z value. And after we find the z value, we plug this thing right here. A very, very, very common mistake is that people write that 0.3085 is equal to this. They put in the percentage for the z value. That is completely incorrect. Right? Is everybody good with that? We don't put the percentage there. We find the z value from the percentage, and then we put it there. So this is not right. All right, is everybody good with those concepts so far? All right, then let's go and do some examples. Now, these are a little bit closer to what you're going to start seeing a little bit in your homework and on the exam. I left away a lot of the flowery wording again. But essentially you're going to say, hey, find an x star. This x star is the x that you don't know, such that the probability that x is less than x star is equal to this, so they're giving us the percentage. And x is a normal random variable with a mean and a standard deviation, right? The other part that people sometimes get confused on is reading this thing right here. Right? Reading this thing right here. They're saying, well, which direction do I shade? Like, what do I shade to the left? Do I shade to the right? Do I look at the X? Do I look at the X star? And then especially if you're on a test and like you're nervous anyways, and you're just like, and then you start freaking out and you get everything wrong, right? Or not, maybe you just get everything right. But you're going to freak out nevertheless, and freaking out is never a good thing, right? The easy way to solve this is this. We've never seen X star before. We don't like things that we're not used to, so let's just scratch it off. Right? Let's just get rid of it. All right. Now it's gone. You can replace it with your favorite number. I like the number 7. Right? If you had to shade this right here, where would you shade? To the left of 7. Right? So to the left of something. So we know that we're going to be shading in to the left of whatever your favorite number is, or technically, it's whatever number that you're looking for. Right? So now we know that to the left of something, we need to have 0.9332. Right? To the left of something, we need to have 0.9332. Is that going to be a positive z value or a negative z value? Positive, right? To the left of something, we need to have 93%. So we're definitely way past half, so we're going to have a positive z value. Does that make sense? Let me say that one more time in terms of a picture. Here we have our distribution. To the left of some number, we need to have 0.9332. So to the left of some number, is that number going to be right here? No, it's not, because to the left of this, it's impossible to have 93%, or approximately 93%, right? 0.9332. Here we're at 50%, so if we want to get all the way up to 0.9332, we have to shade all the way up to past 50% of our distribution. Well, over here, right now, if we get rid of this again, what we originally had right here was X star. X star should be somewhere way over here. So if we convert X star to a Z value, we should be getting a positive Z. Right? Is everybody good with that? All right. So we should be looking up a positive Z value. Everybody good that for A, we should be looking up a positive Z value. Right. So then let's do it. We're going to we have Z is equal to X minus mu over sigma. You guys starting to see why this equation is so super important? We just keep coming back to it, right? Whether we're converting X's to a Z or whatever. And even up here in the definition, like I said, I don't really like this definition. It's not that it's a bad definition, but whenever you try to read the definition, like it's kind of hard to process. All that this is saying is just rearranging this formula, right? If you solved this formula for X, you would multiply both sides by the standard deviation. So then you would have Z times sigma is equal to X minus mu. And then if you solve for X, you would have Z sigma plus mu is equal to X. Well, that's just the same thing as it is up here. Right? So it's just the same formula. Why try to remember another formula? Since I said, hey, remember Z is equal to X minus mu over sigma, and everybody here is awesome with basic algebra. So therefore, we can just stick with this one right here. All right, so we're trying to find our X. We know that mu is equal to 10 and sigma is equal to 2.5. And we're looking up 0.9332. And if you look up 0.9332 in your table, what do you get? 1.5? Is everybody good with 1.5? I think I'm good with 1.5. Let's see. Yep, I'm good with 1.5. Right? And just to make sure that everybody's cool with this, 0.9332, that's a percentage. It's not a Z value. I know I'm repeating myself, but this always comes up later on. So 0.9332 is a percentage. It's not a Z value. We use that to find our Z value, and our Z value is 1.5. Again, we're looking for X, or as a problem calls it here, we're calling it X star. Potatoes, potatoes. Now what are we going to do? we solve for x, we're going to multiply both sides by 2.5 and subtract 10 from both sides. And then we should end up with x star being equal to 13.75. Right, because we're adding 10 to both sides, not subtracting 10 from both sides. 13.75. Everybody good with 13.75? All right. Take a minute or so for yourself and see if you can do the next one by yourself. All right, anybody need a little extra time? Then let's do this one together. All right, so what we're trying to do is we're trying to find x star. And the easy way to do this is simply just to use our formula of z is equal to x minus mu over sigma, where here it should be understood that x is the same thing as x star. What we can do now is we can substitute in our mean into this formula, which is 12, and we can divide it by our standard deviation is 5. And again, we're still just looking for x. But now we're also not given a z, but what we are given is we're given this percentage, right? 0.0427. So here's the important point about 0.0427, and it's important that you guys always go through this thought process. Just like I did before, a lot of times people get confused about which direction are we shading, right? Just like we did before, cross this out, call it your favorite number. I'll choose the number 7 again. Which direction are we shading? Again, to the left of 7. Right? Is everybody good to that? Good with that? So, to the left of 7, or any number that you want, right? We'll call it x star here again in a minute. To the left of something, we have 0.0427. Is that going to give us a positive z value or a negative z value? It's a negative z value, right? Is everybody good with the fact that it's a negative z value? All right. So now if we look up 0.0427 in our z table, what z value does that give us?
Negative 1.72.
Negative 1.72. Let's do it 0.0427. You're saying it's negative 1.72. Yep, exactly right. Negative 1.72 gives us 0.0427. And then if we follow this out, right, that gives us our z value that we're looking for. All right, so we have negative 1.27 for a z value, and we can plug that in right here. All right, so everybody good with that? So then we should be able to solve for x by multiplying both sides by 5, and then adding 12 to both sides, and if we do that, should end up with 3.4. Everybody good with 3.4? Any questions about B? All right, we're slowly but surely running out of time, so let's do C first together, and then with whatever time we have left, we'll do D after that. All right, so again, we're trying to find x star. Whenever it says find x star, that's like our buzzword for using z is equal to x minus mu over sigma. We know that our mu is again equal to 10 and our sigma is equal to 2.5. We're trying to find x, or which our problem is calling x star, and we also don't know our z value. And then this is where that thought process that I keep asking you guys to do comes really, really, really important. We can get rid of this x star right here just to conceptualize it. We can call this some number. Again, pick your favorite number. I just keep picking 7. Now, which direction are we shading? Shading to the right of some number. Right? To the right of some number. And we only have 0.123 to the right of that number. Is that going to give us a positive z value or a negative z value?
Negative.
It's not negative.
The 0.1230 would be negative, right?
This right here, if you just look this up, that would give you a negative z value.
Yeah.
Right? But if you shade to the right of some cutoff, right? We're shading to the right of some cutoff. Right? Is everybody good with that? And to the right of that cutoff, you have 0.123. To the right of the cutoff, you have 0.123 as a distribution. Is that going to be a positive z value or a negative z value? That has to be a positive z value. Good. So here, let me draw that out in terms of a picture. We're picking some cutoff, and to the right of that cutoff, above that cutoff, right? That's what that thing's right here says. You have to go above that cutoff. We're going to have 0.123 of our distribution. If that cutoff were right here, is it possible to have 0.123 above that? No, above that we have at least 50%, right? So if our cutoff was right here and we want to go to the right of our cutoff, this percentage right here should be above 50%. Right? Does that make sense? That if our cutoff was right here and we're going to the right of our cutoff, then this percentage right here should be above 50%. But it's not. It's below 50%. So therefore, because to the right of our cutoff, we have less than 50%, we have to have a positive z value. Right? Is everybody good with that? Anybody want me to say that one more time? Again, some people who are giving me the squinty eyes, like, what? Are you sure? Let's go over it one more time. If we have some cutoff, and we want to go to the right of the cutoff, if the cutoff were right here, what would be a reasonable percentage that we would have? 70%. Right? Is everybody good with that? A reasonable percentage for right here would be like 70%. Right? Could be 80%. Could it be 40%? No, because we're shading in more than half. Right? So therefore it has to be above 50%. Is our percentage above 50%? No. So therefore our cutoff can't be below the mean. Our cutoff has to be above them. Right? Over here, above this cutoff, it's reasonable that we have something that's less than 50%. But the only way that we're ever going to be over here is if we have a positive z value. Right? Is everybody good with that? So therefore, our z value has to be positive. Everybody good with that? Whatever we're going to do from here on out doesn't matter, right? have to be using a positive z-value. Everybody good with that?
Yes.
All right. So we have to use a positive z-value. This thing has to be positive. But now what are we going to do?
What do you do with 1 minus?
We could subtract it from 1, but the process that we always have been going through is, let's look up 0.123, right? That's what we've been doing in the previous problem. So now let's look up again, right? Let's stick to the process. The process says look up 0.123, and if you look up 0.123, what do you get? Negative 1.16, right? You get negative 1.16. So you're saying, all right, cool, z-value is negative 1.16. However, what we just said was, it doesn't matter what we do from here on out, we have to use a positive z-value. So just change this to a positive 1.16. That's all you can do, right? So that's one way. That's if you follow the process, right? The process says, find x, write down this formula. Then after you write down this formula, substitute in mu and sigma because we know those. Then we said scratch away this thing right here, find out which direction we're shading. After we figure out what direction that we're shading, figure out what percentage we have to the left or to the right of it, depending on which direction we're shading, to find out whether or not we need to have positive or negative z-values. Then the next step in the process was to look up this percentage. And now what we said is if we look that up, we get negative 1.16. But we have to be using a positive z-value. So therefore, we're just going to change this from negative 1.16 to positive 1.16. Right? Or, as Rachel said, she said, hey, wait a second. One of the things that we could do, too, and Tyler mentioned this a couple of classes ago, right? Another thing that we could do is we could just say, hey, we're shading to the right of this. Right? We're shading to the right of our cutoff. So one of the things that we could say, too, is we're all in agreement that this right here has a percentage of 0.1230. Right? Everybody's cool with that. Well, our table never gives us what's shaded to the right. Our table always gives us what's shaded to the left. Right? So then what we could also do is we could just say, hey, from here on down then, we should have a percentage of 0.8770. Right? Now look up 0.8770 on your table. If you look up 0.8770 in your table, it's positive 1.16. Right? Because now you're just finding the opposite side of it. Right? So that shouldn't be surprising. What should not be surprising is this. What should not be surprising is that from here on down in our table, we have 0.123, which is a negative z-value of 1.16. And from here on down, which is a positive z-value of 1.16, we have the rest of it, which is 0.8770. Right? Because all that we're saying is here is that this amount is this amount. So therefore, if we want to find out z-value of 1.16, one of the things that we could do too is just find a z-value of negative 1.16 to know that these two things are going to be equal. Right? All we're just doing here is flipping stuff and going positive and negative and stuff like that. If you do it a lot, it gets confusing, right? It becomes like a hand trick, right? Like, hey, where did it go, right? But you guys already know how to do this. So you can either follow the process, like I've said, where we're scratching this out, we're figuring out our percentages, we're looking those up in the table, and then we're using that z-value. Or you can do it like Rachel suggested, to say, hey, if above here I have 1.23, I can subtract this from 1 to get me from what's here down, knowing that my table is going to tell me this value right here too. All right. So we went over today, so we'll leave it here with that. We'll pick up tomorrow with D, but then after we get done with D, we'll just hop straight into Chapter 6. All right, I'll see you guys tomorrow.
I was just wondering, I was kind of absent yesterday, right?
Yes.